Okay, so as we get into chapter 3 now, where we're going to be talking about functions, first thing to remember when writing an equation, when we use this f parentheses x and an equal something, right? This f parentheses x stuff, remember, that's called function notation. And we're going to review that a little bit uh, more later on, but just kind of pointing that out. Remember, that's not f times x, right? In fact, uh, that is in fact uh, a notation that indicates that f is a function of x. So in chapter 3, we're going to be looking at functions, or specifically graphs in terms of a function idea. So in 3.1, we review some of the ideas of a function. And so we first begin with a definition. A relation is a mapping sometimes called a correspondence, an association, a matching. From objects in one set A to objects in another set B. So a relation is a mapping or correspondence, or matching again is another word you can use for objects in one set to objects in another set. Where the objects in A are related to the objects in B by the relation. The relation simply tells us what objects in A are related to what objects in B. Now it could be a simple, excuse me, it could be a simple list of these are the things, they're related. Yeah. Perhaps you're at a family reunion and we want to start relating everybody that they're blood related to, right? They have a common ancestor, you know, in the recent past. So perhaps something like that. Uh, okay. And then everybody gets related by those that they're related to. In other words, they have a common descendant. Let me show you another example here. Let's say that A is equal to the set of students in a class. And that is also what set B is. So A and B are actually the same set. So set A is relating the students to themselves in some way. And let's say that the relationship that we're looking at is quite simply is taller than. And let's just say that our class happens to consist of only 4 students. Alan, Bill, Chloe, and Dana. So we have this class with only 4 students, Alan, Bob, Chloe, and Dana. And perhaps we know the following is true. That Bill is taller than Alan, is taller than Chloe, is taller than Dana. Yeah. So that's what we know about the heights as far as those 4 students. So from this, we could indicate our relation. And one way to do it is to use what's sometimes like a matching diagram. Right? You've done this in the past when you've done tests, where you're given a list of things on one side, right, and you match them to things on the other side. Now, typically, in those situations, you were dealing with different things, but here we could say, here's our set A, letters A, B, C, and D for abbreviation. And over here we have our set B, with students A, B, C, and D. So anytime you've done something like that, you've actually been dealing with relation, where you have matching things from one side to the other. Now, in the easiest ones of those, everything on the left side, each one would get related to one thing over here. Those easiest relation problems, you would do that. But then in some of the harder ones, you might have stuff over here being related to multiple things over here. And that's what we actually find out here with as we look at Bill. All right, Bill, we know is taller than Ellen, so we can draw a line from Bill to Ellen, all right, to indicate that Bill's related to Ellen. But Bill's also taller than Charlie, or not Charlie, Chloe. And Bill is also taller than Dana. So we have a line going from B to all 3, except Bill's not taller than Bill. And then we can keep going. Ellen is taller than Chloe, and Ellen is taller than Dana. Okay. And finally, Chloe is just taller than Dana only. Okay. Chloe is just taller than Dana only. And so we have this relationship. A is related to those, or B is related to those 3 things. A is related to 2 things. C is related to 1. D doesn't have anything related to it. D doesn't have anything related to it. Now with this set, we go a little bit further and define some more things. Okay. We say the set of elements, or objects, another name for those is objects, set of elements in A that are related to something in B is called the domain of the relation. It's called the domain of the relation. In other words, it's the stuff that's going into the relation. It's the input. It's the input of our relation. So in our problem up above here, the domain would quite simply be objects A, B, and C. Right? Those would make up our domain in this particular problem. Okay. Dana is not part of the domain because Dana is not taller than anybody in the class. Okay. In a similar fashion, we can talk about the other side there. We refer to those as the set of objects in B, set of elements in B, that have something related to them from A is called the range of the relation. So think of this as kind of the output. Once we put something into the relation, the stuff in B is the stuff that the relation is spitting out. That's our output. So if we go back up to this problem here, the output is objects A, C, and D. B did not have anything related to it, and so therefore B is not a part of the range for this relation. Okay. So we're going to take these ideas now that we have, that we've built up in these examples here, and we're going to now use these to start talking about a function.